autonomous stuff started in 2010. We were the first company in the world that you could buy an automotive-grade radar from if you weren't an OEM. So we created a channel back in 2010 with the foresight that this was coming to get the technologies into the hands of researchers such as machine vision cameras, Lidar, radar, so they could start using this technology to develop autonomous perception systems that would then go into cars. Since then, we've grown massively. I think from 2014 on, we basically tripled in size until this year. This year, we were acquired by a company called Hexagon, so we're part of a large Swedish conglomeration now that does factory automation, geospatial positioning, and a couple other industries. We are worldwide. We have offices in Europe and China, Silicon Valley, as well as central US. And we'll continue to grow into this next year with more technologies and platforms. And this is kind of a weird slide, but this talks about when we thought autonomous cars would come, right? So back in 2004, when the DARPA challenge happened and when Velodyne really started sowing their roots, we all imagined that this isn't really going to happen. We're going to have autonomous cars. In 2009, when Google had its little clown cars driving around Mountain View, it started to look a little more positive. We're thinking maybe 2050. Come 2016, with Cruise being purchased for $1 billion, it then seemed a little closer. Coming down to 2025, now we have Chinese startups that are already doing autonomous robotaxis all over China. We've got Google opening up in Arizona this year, a bunch of other cities. So it seems like it's just about here. Quite a big change from where we were just about a decade ago. And then the customer landscape is changing a ton too. You would think that we would work with traditional car companies, but there's maybe only 2 or 3 traditional car companies in this list. So you have customers like Baidu that are information companies going after the vehicle market for the information technology wealth in there, as well as mapping. Of course, NVIDIA with GPU technology, we're using this on cameras. Different software companies like TuSimple, doing vision perception software. So a lot of different players in here that you wouldn't really expect in automotive. Similarly in China, and these guys, Plus AI, Pony, are all doing autonomous taxi in Shenzhen today. So pretty amazing stuff. And our ecosystem partners, again, not traditionally automotive. The ROS organization, if you're not familiar with robotic operating system, a lot of the data fusion software we provide runs on ROS. And then we're also working with companies like Samsung and Clarion. And of course, all of these guys want to understand, A, what information is available for us to monetize in this new autonomous world, and then B, what sort of silicon do we need to produce to kind of support all the operations that are going to happen inside cars. And if you're really anywhere in the world and you see an MKZ that has some sort of roof rack set up on it, or even a Ford Fusion, chances are it was built by autonomous stuff. In the last 20 months, maybe 2 years, we've done about 400 vehicles, including MKZs, Lexus, semi-trucks, and even small NEVs. And as you can see, they're all very different. They're all kind of designed for specific use cases. TuSimple is all about highway driving. They're going to be interested in really longer range perception. Pony and Jingqi and Baidu are doing more taxi types, lower speed, deep, urban canyons. So they'll have different positioning and perception systems. And then Roadstar has a really interesting technology that they can change coordinate transforms of sensors depending on what vehicle they're in. So pretty cool stuff happening overseas. And then you can see our kind of distribution. Of course, a lot of the development happens in Silicon Valley, even if it's developed there and then kind of repurposed in China. We have now offices in China, Japan, as well as Germany and Detroit, and everything's kind of happening in a different way. I got to say, China's moving at China speed, as Baidu says, already deploying things, and I think we're going to kind of catch up with that in the US this year. Germany is a little further behind from the regulatory standpoint and driven a lot more by OEMs, but I think we'll see a lot of growth in autonomy over the next year in Europe as well. These are the kind of foundational parts of autonomous stuff. Of course, I mentioned earlier we started out with products. We are a distributor from the beginning and continue to be. We're always out looking for the latest and greatest to bring to customers. We're continually increasing our services. So this means services for integration, services to test different software modules. integration services, design services. So always growing that, and really growing that in China and Silicon Valley significantly this year. Software is really the silver bullet for autonomous driving. I think the technologies that Velodyne has and others have are really kind of there from a performance standpoint. It's just a matter of creating the right software in a way that we can assure that the cars operate safely. So today, Autonomous Stuff is offering LiDAR object segmentation software, shuttle automation software, data fusion software. Platforms. So we bring our products, services, and software. We deliver vehicles too. So this includes the Lexus, the MKZ, a number of different semi-trucks, and some small electric vehicles. And if you have a vehicle that you want to be converted to autonomous, like a by-wire interface, we can create that too on most vehicles. And then the last bit of this is data intelligence. I think 2 years ago when I started with Autonomous Stuff, I was like, we're going to saturate this market with cars. What do we do when everybody's got an autonomous car? And the answer is you put a big giant hard drive stack in the back because the autonomous car creates a ton of data. So with our data intelligence offering, we're putting up to 100 terabytes of data storage in a car that can ingest data at speeds up to 10 gigabytes a second. And then this would then connect to a larger data center in a garage that could ingest all that data for training and annotation purposes. And then if you think about the industries, it's not just automotive, of course. Automotive is a big part of this, but of course we've got maritime automation. There's a lot of gains you can get in efficiency by having a boat or a ship controlled autonomously, calculating the tides and currents and wind. Of course, the military applications. Military's been doing platooning for 2 decades now. And robotics. Of course, this is just a robot that we're going to ride around in. So a lot of the techniques we're using in industrial automation, or used in industrial automation, are being redeployed onto the road. Aerospace, of course, all sorts of neat things happening there with SpaceX, as well as drones that will pick you up from the top of a building and deposit you on another building. And of course, driving all this are startups. So I'd say that 30 to 40% of our business is with startups, if not more. And then even in agriculture and mining, of course, mining's been doing autonomy forever, but we're bringing novel sensor suites to mining, better positioning, better cameras, similar with agriculture. Agricultural positioning is great, but they haven't used advanced LiDAR out there ready to be used today. And then the applications we're talking about, of course, autonomous driving. That could be autonomous driving of a car or a delivery vehicle or a plane. And then 3D mapping. 3D mapping is really the core to autonomous systems today, especially on the road, because you typically need to make a 3D map of the area that you're going to navigate through in your autonomous vehicle. So, of course, Velodyne sensors are tailor-made for making maps. And if you look at most of the HD maps that are available today, they're all made with the old HDL64. And there's a huge amount of money in this 3D market. So an HD map of the state of California will run about $22 to $30 million today. That's to get a map with kind of every road and every street sign in the state. So a lot of money there. Of course, if we've developed a bunch of systems that can detect people and objects and animals on the road, I can also deploy that in a security application. It's the same thing. I want to look and make sure there's no people running around the area of an airport where they're not supposed to be. I can use the same camera that I've designed to detect a person on the road to detect a person somewhere where they're not supposed to be. And then, of course, artificial intelligence. This all bubbles up to these systems that then can decide, is this a person, is this a bush, is this a dog? This is done by capturing a ton of data, training that system to know what is a person, or know which way to turn a corner in a car. Kind of the core of all this technology. Remote control and monitoring. Another piece of autonomy that isn't really autonomy is what's called teleoperation. So this is a situation where I've driven my Ollie into a spot where I can't navigate out of it. I'm able to then remotely look through the cameras of this vehicle and drive it from some other space. This is a huge advantage in moving trucks around yards where you don't want to pay an expensive driver to just go move a truck 50 feet. Object tracking and classification, of course, that's the process of using LiDAR or cameras or radar to determine, A, is it something I need to look at and focus on, and then track wherever it goes in the field. And of course, robotics in many different applications. And now I'm kind of even seeing automotive autonomy technologies go back into the factory. So we're getting a lot of good cross-pollination between factory automation to the road and then back to the factory. So what do our platforms look like? So if you imagine the dealer of the future, this is kind of what the showroom is going to look like. You could walk in and buy a fully functional autonomous car of many different descriptions. And the whole top line of these are basically normal commercial cars that you can buy today. MKZ, Fusion, Lexus. All of these cars share certain features such as existing adaptive cruise control, existing active lane keeping. So we kind of utilize those existing systems that are level 2 ADAS and repurpose them for full autonomous control. This whole range of vehicles from here over are what are called NEVs. In the US, you can operate these little electric vehicles on any road with a speed limit under 35. They have a top speed of about 25 miles an hour. So great for campuses, great for small cities. And these can be repurposed into delivery vehicles as well. And then the Polaris Ranger is considerably faster. You can't drive that guy on road, but for an off-road application, maybe mining, this can be converted into an autonomous vehicle. I'll show you an example of that. It's perfectly capable off-road. And then the latest offering are the Class 8 semi-trucks. So we work with Packard to provide a very professional interface with the Class 8 semi-truck that works with Bendix and ZF. And what you end up with is either a Kenworth or a Peterbilt semi, fully autonomous, supported by both Packard, ZF, and Bendix. And then even custom vehicles. If you have a vehicle or you're an OEM and want to create an interface for it, we can assist in doing that. The typical time for that could be anywhere from 6 months to about a year. And then your typical autonomous car. This is the Lexus hybrid that we're now offering this year. And this is just a good view of kind of what is on an autonomous car from a sensing standpoint. Of course, Lidar everywhere. So this could be Lidar on the roof. In this case, we have two VLP32Cs on the roof. This is a configuration that would run a certain software stack that we call AutoWare, which is basically software that can make a map and get the vehicle down the road. But typically in the trunk, we're going to have an ECU, an IMU, a GPS antennas on the roof, typically cameras in the windshield, cameras in the rear view mirrors, cameras on the front. Ultrasonic sensors have existed on cars forever, but now we're looking at actually 3D ultrasonic sensors. And lastly, DSRC. There's a big fight over DSRC or 5G, but there will certainly be some sort of intra-car, infrastructure communications on these vehicles, kind of rounding out the entire autonomy suite. And then some examples of these guys, just semiconductor companies. So of course, Intel with their acquisition of Mobileye certainly put autonomous driving on the map with the amount they paid for that. QNX, which was BlackBerry, is getting into the infotainment world. Visteon, Renesas, NVIDIA, all looking for developing better software, better silicon for the autonomous world. Qualcomm is after that 5G play, right? Going against DSRC. And Hitachi and Clarion are looking at things for like infotainment as well as guidance. And then universities, of course, a lot of the customers we have are right out of university. A lot of the skills you need to work in this industry, like dynamic path planning and machine vision, are very new to universities. So some of our greatest customers and greatest engineers come out of places like Berkeley or Waterloo, and even Texas A&M that's got one of the semi-trucks. So what do we offer besides LiDAR, of course? Actuators to make steering wheels move. Computing, we're always designing special computers to ingest all this different camera information, LiDAR information. And of course that fits in right into the data acquisition. Not only can the computer process a bunch of data, it can also save that data to these huge storage arrays we make. We make enclosures to make stuff waterproof. We develop and deploy a lot of these what are called inertial navigation systems. I'll get into that in a little more detail in a second. And of course, LiDAR. Not only do we sell the LiDAR, we're going to tell someone, oh, if you're going to make an autonomous street sweeper or you're in mining, we're going to recommend some different LiDAR for every different application and put it somewhere differently on a vehicle, depending on where it might need, what it might need to do. And then, of course, vision and ultrasonic and everything else. Quite a broad spectrum and constantly growing. And then it's great, you know, last year when I was here, I think Velodyne didn't even exist yet. Veloray was just here as well as the 128. And it just keeps growing. So this is great to see Velodyne's success, and it really validates the fact that this industry is growing rapidly. And you can see all examples of stuff here. And this is really the holy grail, right? A sensor that doesn't need to sit on top of the roof. It can be integrated cleanly into a vehicle. And I think sensors like this is really what you're going to see on a future autonomous vehicle. And then getting into the more industrial applications, the Velodyne, a little shorter range, kind of, again, repurposing this autonomous car technology, and we can put a Velodyne on a little cart in a factory, start picking up new applications there. So, and this is the kind of kit that you would need to deploy a very basic navigational stack. AutoWare is a company run by a company out of Japan called Tier 4, and this is the equipment you need to put on a by-wire vehicle to make it basically self-driving. We have a computer that can ingest data from the radar, the camera, the GPS, and the Lidar. That computer would also run the stack from AutoWare. And the way this works is you drive around with your Velodyne and your GPS and you make a map. And you end up with a 3D map that looks exactly like the images you see from the Velodyne. And then in real time, you can go back into that map and basically localize within the map using the same sensor that you created the map with. This is what's called SLAM, simultaneous localization and mapping. And that's the basic method for a lot of the positioning we have in navigational systems today. It also requires a very accurate GPS and IMU. And the one thing I'm not showing there is a correction service that we add to that GPS. But this mix of technologies, LiDAR, radar, camera, and GPU, are basically the cornerstones of autonomous driving. And then you add in some ultrasonics and GSRC. All right, so then just a quick view of what do we do. So a lot of engineering and integration. We're not only salespeople, we're going to really walk and hold the customer's hand until whatever system they're trying to develop is out there and running. And that could be a basic consultation to fully building something for them. Training, we're handing these vehicles off to people who might be very smart companies, but it's something they've never seen before. So there's a lot of interaction where we're showing people how to work with the systems, training a lot on the software, how the data fusion works, and then of course consulting just on anything. What sensor do I need? What vehicle do I need? We've developed a lot of skills in the past couple years around that. And then integration. It's funny that you'll go to some of these extremely advanced companies and they don't own screwdrivers or any tools for that matter. So we found a good business in simply attaching sensors to vehicles, finding novel ways to integrate sensors into vehicles. Basically, and that includes cameras, power distribution, computers, cooling the stuff. You can't just jam a giant computer in a trunk and hope it's going to be happy there without using some sort of cooling solution to keep that stuff cool on a hot summer day in Phoenix. And even further up that chain, data collection. Maybe you want me to go get a Ross bag of radar data in the Bay Area. You want us to go get GPS data in a certain area. We can deploy those services on your behalf and then just deliver data for you. So, and we kind of do these, we're just holding the coattails of our customers, looking for opportunities to help them move quicker, and these are just some examples of that. So this is a new facility we built in Morton, Illinois. We had, I think when I started there 2 years ago, a relatively small building. We're growing quickly. So this high bay building, I can put semi-trucks in there, I can work on 10 or 15 vehicles simultaneously. Pretty exciting. And this kind of all happened after we were acquired by this Hexagon group. But certainly top notch and one of the more exciting companies to work for, certainly in central Illinois. And even above that is an innovation center, so we're bringing in PhDs who can solve some of the hardest problems in autonomous driving. A lot of that goes to just creating these interfaces for these vehicles without the help of the OEM. So pretty exciting to have this new facility. And then similarly in China, this is in Beijing, with the help of Hexagon and their facilities. We now have big areas in China to build these vehicles as well, which is a small little start or a kind of a bootstrap company out of Illinois. Is pretty amazing. And then even into software. So as we built more vehicles, did more integration, there was always the question, well, how do I get the most out of my LiDAR? Maybe I want the car to steer in a more smooth way. So in those pursuits, we've developed speed and steering controls to make the car feel like a human is driving it. We're developing full-on autonomous shuttle kind of software, LiDAR object processing for thermal cameras and regular cameras, and speed and steering control. So all of these are kind of key features for autonomy. If you don't have speed and steering, the car's going to feel like it's driven by a robot. Nobody's going to be happy inside that thing. And shuttle automation, which I'll show an example of here, is great software for just deploying a very simple autonomous system. With this software, I can drive one route. So maybe I want to pick up someone at one area and drop them in another area and go back and forth and do that all day long. I can set up that sort of route in about 10 minutes with this software. This uses purely GPS, IMU, and a correction service. So like if you're on a racetrack, I can drive that track once, and I can drive it ad nauseum as many times as I want. And the fun thing about it is I can change the behaviors. When I make the map, it just remembers position. But I literally have insane mode in this software where I can have it just drive like a bat out of hell. So it's good for many different situations, but usually you use on a university campus to just pick people up at a parking garage and drop them off somewhere else. And this can be easily deployed on a basic by-wire car. Lidar object processing, near and dear to Velodyne's heart. This simply looks at objects in the Velodyne, like you'd see in the screen here, and can determine, is it a person? And not only is it a person, they can track that singular object anywhere in the frame, so you don't get confused by multiple targets in your scene. And then data intelligence. So this is that kind of process flow for gathering sensor data out in the real world, bringing it into a computer, bringing it into the garage for classification and labeling, then developing, your deep learning algorithms, your artificial intelligence with it, simulating those, and then actually putting them back on the car. So this is kind of that ecosystem of iterative development of AI. We try to be as sticky as possible getting into the sensors, the data acquisition, kind of consulting on this process, even hooking people up with services to do annotation. And then working with companies like Veer is part of the Hexagon group to do simulation and testing, and then put that software back on a real car. And this is kind of what that equipment would look like. You've got up to about 100 terabytes in the car, and it basically a 19-inch rack. It looks like an IT center inside the vehicle, connecting to petabytes, exabyte deployments inside a garage, and then workstations, and even tape libraries. We use a lot of tape. And the reason for that is I can't put petabytes of data on disk and not go broke. And I can't also put petabytes of data into the cloud and get it back without going broke. So we go into companies and tell them, you got to put it on tape. And they're like, tape? What is it, like 1980 or something? I don't know if you know, but all of AWS and Azure live on tape. So, and the other reason you need to store this data forever is, I'm going to train this algorithm to avoid people, for instance. If then 10 years later, my algorithm doesn't detect a person and it runs them over, I'm going to have to pull all that training data out and present it in court to prove that I trained it properly. So I can't just toss away this data after these algorithms are developed. We're looking at 30, 40-year lifespans of this training data, and it's enormous. So what we've developed is basically this system that can kind of move the data where you want it, when you want it. So we bring the data from the car, we put it on what's called a hot storage tier. This is where your engineers are going to access and kind of work on that data for the next week. If you've not used that data for about a week, it moves it into some other tape library, object storage, even to the cloud. And it does that automatically based on a rules-based system. So this is a way to manage massive amounts of data as we start developing these new autonomous systems. And then a few photos from last year. We had one of our cars there with the keynote speech with Ford. Of course, the BB-8s from NVIDIA, that green one over there is a autonomous stuff car, and just a number of others. And we don't even have a booth here. We have a suite in the MGM Grand, and we plant our cars at other people's booths and stand there. It's a pretty nice way to do a show.